Verification of Maxwell's reciprocal theorem for a given simply supported beam. So these are the apparatus required. So our beam, simply supported beam, is made up of a mild steel having Young's modulus 200 gigapascal. The beam is of length 1 meter, and the supports, the length between the two supports is 780 millimeter. The width of the beam is 16 millimeter, and thickness of the beam is 6 millimeter. So these are the dimensions here. So according to Maxwell's reciprocal theorem, in any beam or truss, the deflection at any point 1 due to the load W at any point 2 is same as the deflection at 2 due to the same load W at 1. Okay, so we'll see that experimental verification by obtaining the readings with the dial gauge and plotting a graph. Okay, so let us explain the theorem from this diagram. If you look at the bottom figure, okay, so you can mark any 2 points on the beam randomly, okay, randomly 1 and 2. Okay, so apply the load at point 2, measure the deflection at point 1. So this delta 1, 2 gives the deflection at point 1 due to the load at point 2. Okay, in the same location, apply the load, same load at point 1, measure the deflection at point 2. So delta 2, 1 is nothing but the deflection at 2 due to the load at 1. Okay, so I will explain in the video. Okay, so these are the readings. So we apply the load in the range of 500 grams, that is 0.5 kg, 0.5 kg, 0.5 kg increment. We'll take some 5 readings. Okay, for example, here I apply the 0.5 kg load. I place my dial gauge here, note down the reading. That is, for example, 27 reading shown in the dial gauge. 27 must be multiplied by 0.01 so that you'll get in millimeter. Then again you add 0.5 kg weight, note down the reading in the dial gauge. Again you add the one more 0.5 kg, note down the reading at 0.1. So like this, for 5 weights in the range of, the incremental order of 0.5 kg, note down the readings at 0.1, okay, which is nothing but the deflection at 1 due to load at 2. These are the loadings. Unloading, remove 0.5 kg or 500 gram, note down the readings again in the dial gauge. Then we take the average of these two, enter here, average delta 1, 2, and this column shows in millimeter. Then the other tabular column, for this, apply load at 0.1, measure the deflection at the 0.2. Similarly, loading and unloading part, average, and average in millimeter. Okay, these are the procedures. Okay, so we are just plotting this x-axis as a load and y-axis the deflection millimeter. We obtained for delta 1, 2 and delta 2, 1. If you look at the slope, is 0.55 or 0.52, so it's almost same. Even you can have a confirmation here in our tabular column also. You see loading and unloading. We look at more or less same result. Okay, same results. So here also you can see here the same results. So by this way, we are experimentally proving the Maxwell's reciprocal theorem. This is the video. This is the video of this supported beam setup. We've taken a 0.1. Here we have placed a dial gauge. Okay, at 0.1. Okay, ensure that 0 point the dial gauge, and another 0.2 where we are going to load the weights. So we are adding 500 gram weight, 500 gram weight, and deflection is being measured in the dial gauge. Okay, the same reading I have taken in my tabular column also. Again, 0.5 kgs is being added. Then again, we are making a note of the reading, dial gauge reading in our loading tabular column. Okay. This is nothing but deflection at 1, you load at 2. Delta 1, 2 we are measuring. Okay. Again, we are adding 0.5 kg. Note down the dial gauge reading. Again, add 0.5 kg. Now totally you have 2 kg on the beam. Note down the reading. Now it has gone one full revolution. That means 100 plus this value. Okay. Again, you add 0.5 kg. So totally 2.5 kgs load is acting on the beam. So note down all the readings and enter in the tabular column, the loading column. Okay. The loading column. Now you unload it. Remove 0.5 kg and then make a note of all the readings. Enter in the unloading column. Okay. You can note down the readings. Okay. We are removing. Step by step, we are removing the 0.5 kg load. Now we apply a load at 0.1 and trying to measure the deflection at 0.2. Okay, ensure that your dial gauge is at zero position. Okay, add the weights 0.5 kg, the range of 0.5 kg till you reach 2.5 kg. So now we are adding 500 gram or 0.5 kg. Make a note of the dial gauge reading. The dial gauge reading multiplied by 0.01 will give you the deflection in millimeter. Okay. Add another 0.5 kg. Make a note of the dial gauge reading, the loading tabular column. Okay, the loading tabular column. And add again 0.5 kg. Then again add 0.5 kg. Last 0.5 kg. Now total weight acting on the beam is 2.5 kg. Now unload. Remove 0.5 kg step by step and note down the readings, dial gauge readings in the unloading column. So these are the readings obtained from our experiments. Okay, so these are the procedures, and you can see a plot here. Okay, and we have studied the Maxwell'S method in solid mechanics. We have done the theoretical part also. Okay, we have assumed some load of 100 Newton is acting some distance. Okay, this is not the same distance that length that we take for experimental also. Just to verify theoretically, okay, we have obtained this deflection expression by Maxwell'S method. Then we apply some distances to calculate the deflection at the specified location, say point 1 or 2, whatever it is. So this gives the deflection at 1 due to load at 2. And the second figure gives you the deflection at 2 due to the same load acting at point 1. So you can see here y1 and y2 are same, theoretically also minus 94.4 divided by EI. So hence the Maxwell's reciprocal theorem is proved. Thank you.